So welcome everyone. Do you have any questions for me on our class, on this network security class? Remember, I did some grading today and got up through, I've graded it, everything's been turned in, unless you turned in the last hour or so. It has been graded. Remember, we're only looking for you to do the packet tracers, the module exams, the packet tracer skills exam, and the written module exams and final. I've actually had somebody finish the entire course already. So if you want to work ahead, you're more than welcome to. The only thing you might run into is turning on the final exam. You need to let me know if you need the final exam turned on. It can only be on for 7 days, so I have to activate it in 7-day blocks. So I will do it as we get closer to the very end of class. I'll start activating it each week. But if you need it before the last 2 weeks of class, say, then you need to let me know so I can turn it on for you. Any other questions? Can you see my screen right now?
Yeah.
Okay. Let's talk about this module. This module gets into something that in several areas that you have not seen before. I actually talked a little bit about them earlier in the class. We're going to look at some of the layer 2 threats and issues and some layer 2 mitigation techniques that we haven't really talked about before that are really interesting. First off, just general opening here. What can you tell me about layer 2 vulnerabilities? What are some of those vulnerabilities?
MAC
Address.
spoofing.
Yeah, address spoof.
Okay, Amar said address spoofing. Bill, what did you say?
Yeah, address spoofing. Yep.
Spoofing, sniffing,
ARP poisoning.
ARP poisoning, where we actually poison the cache and make one machine appear to be a different machine. What happens on a switch? Now, remember, a switch, when we think about how a switch works, a switch actually has a table. And in that table, it deals with looking at, let me find, if I can find the actual picture of what I wanted here. You know, the table, the switch builds a table of MAC addresses and keeps up with every MAC address that's on each port. Well, what happens when you flood the MAC address table on a switch? Mia, do you know what happens when you flood it? If you fill up every single bit of space in the MAC address table,
Then every packet goes everywhere, right?
every packet goes everywhere except for the port it came in on. So in other words,
Right.
if you flood the MAC address of a table or MAC address table of a switch to the point to where it's completely full, it actually acts just like a hub. And it's really easy to do if you use like macOS, or there's so many different little programs on Linux that you can just hit one button and flood the table, and suddenly the switch is acting like a hub. That's one of these main attacks here, this flooding attack. We talk about poisoning or spoofing MAC addresses. We can spoof a MAC address and poison the MAC address table. We can do what are called DHCP starvation attacks, VLAN attacks, hopping between VLANs. That's called double tagging, and it's a little more difficult to do because you've got to kind of understand what the VLAN structure is on the environment you're trying to get through. But we'll talk a little bit about that. We also, when we look at ways to stop some of these attacks, we've talked about them before, which one of them is IP source guard, which is a way to prevent against spoofing attacks. In other words, you're not allowed to send out information from an IP address that's not actually on the router or device that you're sending it from. So you can't spoof an IP address from a device. Dynamic ARP inspection along with DHCP snooping is used to decide ports that are trusted and untrusted. This is actually taught in CCNA, so that you can say that only these ports can send out DHCP server items, which would be the offer and the acknowledgements of the 4 steps of DHCP. And then we learn about port security in CCNA 3, which is really just enabling the port to keep up with the number of MAC addresses on it. And if it exceeds X number of MAC addresses, either shut the port down, restrict the port, or it's protect, restrict, and shut down. So we'll talk about those 3 different items that you can do with port security. One of the biggest things you can do, though, is simply turn off unused ports. Put them into a VLAN that is a black hole VLAN. So if you've got a port that's not going to be used on a switch, put it in a black hole VLAN and then shut it down. And that pretty much ensures that that port is going to be secure. You don't have to worry about somebody using it for nefarious purposes. So here's our MAC address table. We got a MAC address. We've learned about them. Obviously the way the switch does it, it learns all the MAC addresses on each individual port and then uses that to make forwarding decisions so that if it's going from A to B directly, C and D won't see it. If we flood the table on the switch to be full, it actually will send it out every port except the one it came in on. So it just becomes a switch. I mean, a hub, excuse me, a hub. Now, we can fix this by implementing port security. So if we've got a threat actor here that's connecting to a port and they're going to try to run some program like macOS, and they're going to try to run this command right here, which is basically attempts to overwhelm the port with 8,000 bogus frames. Well, port security setup, you've only allowed, let's say at most 4 MAC addresses on a port. Remember, what happens if you only allow 1 MAC address on a port? In our normal environment, 1 MAC address on a port.
It gets disabled if another one is plugged in.
Yep,
Yeah.
it gets disabled if another one's plugged in, if it learns about another one. How many times do our machines actually have more than 1 MAC address on them though?
Depends if somebody snuck a hub on.
Well, it's actually very common though, because what about
wireless access point?
Wireless access points are huge. You cannot put port security on a port that a wireless access point is connected to. It's just not possible. Also, on our regular just PCs, if you're running VirtualBox or you're running VMware Workstation and you don't do the NAT, you know, if you don't hide behind the actual NIC itself, if you expose the virtual machine to the network, it'll have its own MAC address. It'll have its own virtual MAC address. And so I usually suggest, except for really super secure environments where you're going to actually hard set the MAC address and you're only going to allow 1, allow at least 2, maybe 3 or 4 MAC addresses on each individual port. That way you can get away with people trying to spin up virtual machines. This is
Plus, you're not going to starve at that rate anyway, right?
Say what, Bill?
You're not going to fill up the table. You know, if you can allow a few, and you're still not going to fill up the table.
Exactly. Yeah. Even if you're allowing 10 per port,
yeah, right.
that's not going to fill up the 8,000 that's typically available. You know, 6,500 can do 132,000 MAC addresses. But the good news is, if you at least put in port security and only allow 4 or 5, you stop the MAC address flooding issue that could take place. The other thing is you make sure that every port that's not in use is got the same settings on it and is in an unused VLAN and turned off. That way somebody just can't plug in and flood the MAC address of a port that wasn't configured because you didn't think about it needing port security on it. So secure unused ports, turn them off, put them into an unused VLAN, turn on port security, switch port security. Remember that we've got to do that. If it tells you that the port is a dynamic port, that means that DTP is on, which by its very nature is dangerous. So you have to do switch port mode access. That turns off DTP, or dynamic trunking protocol. And then you got to put in the command switch port security. You must put this in or you can't, it doesn't turn on port security. I've seen people do all the commands for port security, switch port security maximum 4, switch port security aging, put in this switch port security violation shutdown. And the whole time they forgot to put in switch port security and just hit enter. Happens over and over, especially in contests. So if you have students who are doing Skills USA contests coming up this month, make sure they know to turn on port security, because it's a common mistake that I see all of the time when I'm grading labs. How can we assign multiple MAC addresses to 1 port? Amar, with that, what happens is this: if you have the one on your NIC, then as soon as you spin up a virtual machine, you will have another one there. So let's see if I got VMware. This is an old version of Workstation. Let's see if it even come up. I might have to do VirtualBox. I don't have VirtualBox loaded on this machine. Let's see if this will even come up for me. Yeah, it will. All right, so here is a virtual machine. If I do a file, remind me later. If I do a file, new virtual machine. Okay, next. Actually, I'm gonna do a custom. Let me go back to custom. Go next. Let's say that. Go next. I'm just going to say it's that one, although that's not really the one I want. I'm saying install it later. It's going to be Windows. Next, 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 next. Okay, now network type. Now here's where you look at, you got some options. If you use bridge networking, then the host will actually create its own virtual NIC with its own virtual MAC address, and it will go in and it will get its own IP address off the system. So my machine will actually appear as two different machines. If I use NAT, it will share the MAC address of the existing physical NIC on my machine and will still only appear as one. If I use host only, that means it's just internal. There's no, absolutely no external networking whatsoever. So if I use bridge networking, this thing's going to create its own NIC with its own external IP address possibility. And it's got its own MAC address. So be aware, that's one way you could end up with multiple. Wow, that'd be nice to have NVMe drives. But that is one way you could end up with more than one MAC address on your individual port.
Which
You
means
also-
there are other ways as well.
Yeah, put a hub in it. So if you had a hub, let's say you took a hub and put it on your desk and you connected multiple PCs to it, you could have multiple MAC addresses connecting back to a port on the switch.
Okay, I got it. Yeah, that makes sense. We had a similar question in the switch it activity.
Yep.
I got it. Yeah. Thanks, Kelly.
Oh, no problem. No problem. So here's how we can set our maximum. Obviously we want to set it some wild number, but 4 to 6. And then here's how we can learn it. It can be sticky, which means it's dynamically learned. So what happens is when the system sees the first MAC address, it will actually put that into the configuration. And if you save the config, it will save it in the config. You can also manually add in a MAC address. So you can actually put switchboard port security MAC address and manually put the MAC address in. If you do that, then you need to know exactly what the MAC address, obviously, of the host is that is connecting to that port. We have an aging where you can set it up to where either absolute or what's called inactivity. So this is how long the MAC address will stay in that port security table. If it's absolute, that means at this particular time, no matter what, that entry will be removed. If it's inactivity, it will only be removed after that particular MAC address is not used for that amount of inactivity. So that's our two types of port security aging. Now, these 3 violation modes are weird, but pretty much we're going to use, if you really want security, you're going to use shutdown, because what shutdown does is if you violate the port security settings, it puts it into air disabled mode, and it will send it increases the violation counter, and it sends a syslog message. You'll notice there's also protect and restrict. Protect is here's a way to remember this. Protect is a problem. Even though protect will discard offending traffic, it never notifies you that anything has gone wrong. It doesn't send a syslog message. It doesn't increment the violation counter. It doesn't shut the port down. So I teach my students that in port security, protect is a problem. Don't use it. You should either be using shutdown or restrict, because restrict will at least send a syslog message and increase the violation counter. I don't really understand why protect is even there. It doesn't make a lot of sense to me. Why bother? If I'm gonna go through the trouble of enabling port security, I want it to tell me when there's a violation. But maybe I've never heard a decent reason why protect exists as a mode in port security. Now, if you ever have one go down, okay, it will show you as an air disabled status. So if you look at it, it'll show air disabled. Now, there are other reasons for a port to go into air disabled besides just port security. It's possible for them to go in this state if they're flapping, if they've got other items can cause them to go into air disabled. But what we typically see is because it is a port security violation. The only way to get out of an air disabled status is to shut the port down and bring it back up. So a shut, no shut. Show port security will show you if port security is enabled. If for some reason you do show port security and nothing shows up at all, more than likely you forgot to put the switchboard port security command as the base command on the interface. So as soon as I do show port security, if nothing shows up, I know what they've done. They've usually forgotten to put that in. And that's pretty much it on port security. Any questions on port security? We should know that pretty well from CCNA 3, 2 and 3. All right, so let's look at VLAN hopping attacks. VLAN hopping is when you do one of two things. Well, it is the same thing, but it's basically you double tag by creating an unauthorized trunk link. You put double tags on it and you try to make your way through the network using those double tags. You will notice that in order to do this, you need physical access to the switch. That means a couple things have had to happen. Number one, the administrator of that switch has already violated the base rule of turning off any unused ports and putting them into an unused VLAN. All right. Number two, they probably have violated the rule of port security. Not necessarily, but probably, more than likely. And here's why. What did I show you and what did I tell you about? If you put switch port security and it says unable to do it because I'm in a certain mode, right? So what was the very first command you had to do before you could turn on port security?
Which port security? Access mode?
Exactly. So if you've got port security enabled at all on an interface, this user down here trying to do your VLAN hopping attack, they may be able to connect because you've allowed 4 MAC addresses, but they will not be able to create a trunk using DTP. Because that port, if you've got port security on it, had to be placed into access mode, okay? So it had to be put into access mode because you cannot put port security on a dynamic port. The reason being, you never put port security on a trunk port. So enable port security, shut down unused ports, and boom, this attack goes away. But you can't do it. Can't create that double tag. All right. So double tagging basically is creating a frame that has multiple tags in it, sending it across a trunk. And then when it hits a switch, the first tag will be removed. The second tag remains, and you're really trying to deliver with this attack malware in the dark. You're just trying to hit somebody on VLAN 20 and get it over there and maybe infect something with some malware. But we fix that by using port security. We also can disable DTP. That's another way to do it. Mitigating VLAN hopping attacks. Make sure everything's in access mode. Disable your unused ports. I always do manual trunks. I don't do any type of negotiated trunking. I don't like negotiated trunks. Switchboard mode trunk on both sides. You got a trunk. You don't have to worry about DTP. All right. Now, this is a concept you've not heard about at all. I mentioned it slightly a couple weeks ago, I think, but we all know about VLANs. So what are VLANs? Virtual local area networks. But Corey, tell me, why do we use VLANs?
This segment or networks, either by function, geography, yeah, one of those.
It could be a room. It could be by, room 122 is its own VLAN. It could be we want all the instructors in this building to be part of an instructor's VLAN, VLAN 20, 30, whatever. Okay. But what if, let's imagine this. Let's imagine we work at a hotel and we want floor 5 to all be VLAN 5. But we don't want Bill to be able to look at the traffic going to Susan's computer or to Mars' computer. We're all staying on floor 5. So we want a way to have VLAN 5, but we don't necessarily want by default all the hosts on VLAN 5 to be able to talk to one another. We use what's called private VLANs, okay? So we can do what is called a private VLAN. We create a private VLAN, and even though that VLAN is its own VLAN, unless a port is promiscuous in that VLAN, it can only talk. It cannot talk between any other port on that VLAN. So obviously, the promiscuous ports here on this would be the port on the router, because the port for the router has to be able to talk to more than one other machine, okay? But isolated ports would not be able to talk to anyone else on those VLANs. So if in VLAN 102, we wanted these two machines to talk to each other, we would make a private VLAN and either make it a promiscuous port or a community port, probably a community port instead of a promiscuous port, so they could talk to each other. But if this was the 5th floor and we made it VLAN 105 and we didn't want everyone to be able to talk to one another, we will make each port an isolated port. And it will only be able to talk to other promiscuous ports. So we'd make it to where it's all on VLAN 105. The sub interface on the router is on VLAN 105, but it's in promiscuous mode. All other ports are in isolated mode. And now suddenly, even though they're even all on the same network, they're still on 10.10, 10.100.100 or 10.100.105.0/24. They cannot talk to one another. They can only talk to the router. It's a private VLAN.
Did you mention this in our DMZ discussion?
It's another great use for it is in the DMZ, correct?
I do remember now.
Yep. Yep. So imagine that you had, I don't think we have a good picture here of one, but let's imagine we have a DMZ, and in our DMZ, we have an email head-in server, we have a web server, we have a DNS server. We don't want to have to create 3 separate VLANs. We just want one VLAN. So we could create a VLAN 50, but we make each one of those ports isolated. The one port on the router or the firewall in the DMZ that's handling the gateway functions for those would be in promiscuous mode. Now, those 3 are isolated from each other. So if someone were to break into your web server, they can't get your DNS and vice versa. So a very well-known use for these is on DMZs. But I'd really never thought about the idea of a hotel until I actually did some digging and did a little research on this particular topic. And the idea of using it on a hotel or anywhere that you want the ability to have a VLAN, but the individual machines not talk to one another on that VLAN. Okay. So it'd be very difficult. And, you know, it's called a proxy attack, but a VLAN proxy attack, you can actually set it up to where you can deny the ability of source and destination to go to the same ports. So you basically deny traffic with source destination that belongs to the same subnet, and then you assign it to a gig 00, and it keeps them from being able to hit one another or go to one another. By default, it really would not be able to get to it anyway if they were both isolated ports. The other item here is, again, some applications, they need no layer 2 port in between the same switch. So your neighbor does not see it. So here's an example of restricting it. If you didn't have a promiscuous port, you could set up, this is basically PVLAN edge feature. This is what I call poor man's private VLAN. So it's only certain types of switches support this. In fact, the 2960s don't really support private VLANs, but they do support this PVLAN edge feature. And so you set up these protected ports, and those ports cannot talk to one another, even though they're in the same VLAN. Just kind of again, it's what I call the poor man's private VLANs, if you don't support full private VLANs. There's a good little video you can watch on this. It's not a difficult concept, but any questions on it? Can you see how it's useful, especially in the DMZ? Huge in the DMZ. Can you think of any other uses? I couldn't think. DMZ, hotel rooms. I could see it in imagine an environment like a convention center, where maybe you have a convention floor and you are leasing out individual ports on that floor to individual users. Then you could create a private VLAN on each one of the private VLAN port on each one of those, so that those individuals couldn't interfere with one another. That's another idea I could see. Any questions? Let's talk about DHCP attacks. We all go ahead.
Oh, I got one question on this private VLAN. I could see that happening in every LAN. I mean, we're always wanting to talk to the server. We're not talking to each other, right? I mean,
typically we don't talk to one another. You're right.
yeah.
Yep. Typically we do not talk to one another.
I mean, yeah.
the question becomes, do you want to go through the trouble to do private VLANs on every single one of your network, every one of your VLANs?
Yeah, that would be a lot. Yep.
Yeah.
Yep.
Now, in a high security environment, yes, most definitely. But you need to ensure and you need to make absolutely sure the two ports don't need to talk to each other. DHCP attacks, some of the more common ones are starvation. So we make you run out of DHCP addresses. That one's bad, but the really bad one is spoofing attacks. And that's when I put out the wrong default gateways and you come to my machine and then I just act as a man in the middle attack between you and your destination. Now, one of the things about DHCP that we all know, it's got the 4 steps of discover, offer, request, acknowledgement, or good old Aunt Dora. Each machine sends out a DHCP discover, the server send out a DHCP offer, and typically the client will then send out a DHCP request, and it will send it to the first offer it gets. So if you can make your rogue DHCP closer to the DHCP client than the actual DHCP server for the network, it can respond quicker and hand out an ACK. And then suddenly what happens is this client thinks that, you know, this machine with an IP address of .101 is the default gateway and it's going there. And this rogue DHCP server is just then forwarding traffic out to whatever router needs to really go to. And it's pulling all the information and watching all the traffic go through. We can fix this with what's called DHCP snooping. And with DHCP snooping, we determine what ports are trusted ports and what ports are untrusted ports. The untrusted ports are not allowed to send out the offer or the acknowledgement. So in other words, you cannot put a rogue DHCP server out here because any offer or acknowledgement will be declined at that untrusted port. We do have to turn on DAI or dynamic ARP inspection for this to work, but it is one of those things where it's pretty simple to set up. And something we really should set up in all of our networks if we're not doing it already. So here we have IP DHCP snooping that turns it on, trusting 01, and then everybody else is not trusted. So basically, if you're trusted and untrusted, you trust the port 01, everybody else is untrusted. You also see this snooping rate limit that only allows up to, that's the number of DHCP requests that can come in at a time. That is a way to try to help mitigate the starvation attack. It's not going to stop it completely, but it does help. And again, you've got to have DAI turned on, which helps mitigate some of our ARP attacks. So let's go down here and look at the ARP attack here. So dynamic ARP inspection, we talked a little bit about ARP spoofing and attacks, but with DAI, what we end up doing with this is it will not relay invalid or gratuitous ARPs to other ports. It intercepts ARP requests and replies on untrusted net ports. So in other words, if it's not trusted, it can actually stop the ARP requests. It tries to stop invalid IP to MAC bindings by looking at the existing table. And it can even air disable a port if the number of ARP packets is exceeded by what you set. But we set up DHCP snooping globally. We enable it on selected VLANs. Then we enable DAI and configure our trusted interfaces. So let's go ahead and look at this. So we got our snooping turned on. We're going to snoop for VLAN 10, and then we got to turn on DAI for VLAN 10 or it won't work. And then we determine which port is trusted for DHCP snooping and which is trusted for DAI inspection. So you got to have both of these for DHCP snooping to work. But once you do, it will go in and attempt to block rogue DHCP servers. It'll attempt to block rogue ARP requests. It'll try its best to stop and mitigate these ARP attacks. Now, again, spoofing attacks, they're difficult, but one of the things is with port security, you also can do a thing called source guard. Basically, the untrusted port will look at the port and we'll figure out what IP address is on it and what MAC address is associated with it, and make sure that that is the actual MAC address that's coming through that port to ensure that it's not someone spoofing a MAC address or spoofing an IP address, either one. Pretty simple to set up, verify source. What's the problem with enabling all these things? DHCP snooping, DAI, all of these. What's the problem?
Resources.
Resources, exactly. Make sure your switches can handle it, because as soon as you do this, you're adding all that additional processing to your devices. Now this one, as far as trying to determine or control spanning tree, the big thing about spanning tree is we want to make sure we're controlling who is going to be the root and who is not. We also want to make sure that we're running a version that is fast and available. There are other versions of spanning tree we don't talk about in CCNA. One is called MST, which is multi-spanning tree. By default, we have a spanning tree instance per VLAN. So it's per VLAN spanning tree. You have a large number of VLANs, you have a large number of spanning tree instances. That's a large amount of RAM and CPU to keep that up. In later learning, when you get to CCNP, you'll learn about a thing called MST, or multi-spanning tree instances, multiple spanning tree instances. And with that, you can take, let's say, I want VLANs 10, 20, and 30 to be in an MST instance. There'll be one spanning tree instance for those 3 VLANs. And then I can do another spanning tree instance for the next 3. That is something that is possible. Really, when it comes down to stopping attacks on spanning tree, we don't really stop the attacks as much as we control the spanning tree to ensure that we know what the root bridge is going to be, to ensure traffic is efficiently moved across our network. Quick question. What becomes the root bridge in spanning tree? Does anybody know? Become the root bridge. What is determined? What uses that? What is
The priority, but they all have the same priority, and then it's the MAC address.
right? It's the bridge ID, and the bridge ID is made up of 2 items. It's made up of the priority, which is always by default 32.768 plus the VLAN number, dot the MAC address. So if you don't change the priority on the switches, they're all going to have the same priority. So the one that will become the root will be the one with the lowest MAC address. Here's how you remember things about spanning tree. Someone walks up to you, points a gun at you, and says, I'm going to shoot you if you don't jump off a bridge. But you get to pick whatever bridge you want. You're going to pick a bridge that's a ½ inch off the water and jump off it. So in spanning tree, it's always the lowest. Okay. So in this case, if we had not changed any of these items, S2 would have ended up being our root bridge. But in this instance, using either the spanning tree root primary or changing the priority by actually changing the root priority on it, it was modified so that S1 would become the root bridge. So you need to make sure you're controlling that in your spanning tree environment. Otherwise, you can get into some serious trouble. Plus, you just have inefficient networks, and that's a bad thing. So spanning tree attacks, one of the things folks can go in and try to change priorities, or they can throw in a switch, illegally put a switch onto your network. Well, here's one of the things. This will never work if you're not using DTP. If your unused ports are put into a unused VLAN and are shut down, and then all other ports are in access mode or manually configured as trunks, unless they can get into your wiring closet and literally stick their device between your 2 switches, they're not going to be able to get involved in your spanning tree. You also can do things like root guard, port fast, BPDU guard. If you put BPDU guard on user ports, in-user ports, and someone hooks a device in and tries to become a switch or act like they're a switch, that port is immediately placed in air disabled status. So BPDU guard and will stop any port that sees a bridge protocol data unit come into it. So you'll notice we'd put in loop guard on each of these ports. We would put in root guard on the root ports, and we would put in BPDU guard on any access ports. Honestly, BPDU guard on your access ports is that and port fast are the 2 fastest ways to stop any spanning tree attacks. Because it just, as soon as they configure to connect to it, it'll go down. Okay. We got some good labs on that one, by the way. That packet tracer is a pretty good lab. Out of these, items that we talked about for layer 2, were any of them something completely new to you? Something you never heard of before?
No.
Now, I think most of these you've heard of before. However, your students may not have heard of them, especially private VLANs. They probably will not have heard of those before. Okay, everybody, we will next week blow through 15, 16, 17 pretty quickly because those are easy ones for us to blow through. And then we'll get up into and spend a couple last few weeks looking at the ASA, because the ASA is going to be very different from what you worked on before. And we'll play with it and get there. So any questions?
I don't have any.
All right, we will have class next week. So make sure you're here next Wednesday. I hope everyone has a great weekend, a great Holy Week, and take care of yourself, and we'll see you next Wednesday.
Okay,
Thanks,
bye.
Billy.
Thanks, man. Take care.
Thanks, everybody. Have a good one. Bye-bye.